and thank you for listening to AI Success Factors podcast. We help enterprise adopt artificial intelligence. This is Samuel Matthew, your host. In simple terms, AI adoption is a three-step process: identifying the right AI opportunity, tying it back to a business value, and aligning it to a business goal. If you're a leader, needs help demonstrating ROI on your existing AI initiatives, or want to get a buy-in for a new AI initiative, you are in the right place. Our mission is to empower enterprise leaders to navigate, transform, and lead by applying AI into their business. In this show, we interview analytical and business leaders who successfully implemented AI into their business. In the conversations we feature, you will learn how these companies reach strategic business goals. It's a pleasure and privilege for our listeners to develop a point of view from the insights shared in this podcast. Today's guest is Sunny Bajaj, Head of Infrastructure, Data and AI at BNSF Railway, one of the largest freight railroads in North America, with $22 billion in revenue and a workforce over 35,000 employees. Sunny is a visionary leader at the intersection of operation and innovation, where safety, scale, and system intelligence converge. With a strong track record in deploying AI, machine learning, and cloud platforms across highly regulated, asset-heavy environments, Sunny has been instrumental in building predictive and autonomous systems that transform railroad operations. From track geometry monitoring to computer vision-powered wheel diagnostics, his work exemplifies how modern AI isn't just support function. It's a strategic enabler for safety, efficiency, and data-driven decision-making at enterprise scale. In this episode of AI Success Factors, we dive into how AI is redefining freight transportation. We explore Sunny's approach to scaling predictive maintenance, building real-time decision systems, and creating a culture of adoption through cross-functional collaboration. You will hear about real-world use cases from sensor-enabled locomotives to edge compute vision systems, and what it takes to turn AI from an experiment into enterprise-wide impact. This is a must-listen for CXOs and data leaders navigating transformation in complex and regulated industries. Here is our conversation. Hey Sunny, I am so excited to have you on the show and talk about applications of AI in railroad freight transportation. Rail is high volume, high precision, and high consequence business. Unlike other freight modes, railroad has a unique blend of fixed infrastructure, systemic impact, and sustainability value that makes it powerful but complex candidate for AI-driven transformation. What fascinates to me is, with the rise of AI, the sector is reimagining everything from infrastructure health monitoring to service optimization. What once relied heavily on tribal knowledge, experience, and manual intervention is now being re-engineered with predictive algorithms, real-time data integration, and increasingly autonomous decision-making. And this shift isn't just technical, it is strategic. You have impressive experience leading AI initiative in infrastructure-heavy operational systems. Can you give a brief overview of the railroad freight transportation landscape to set the context for our listeners?
Yeah, thank you, Samuel, and thank you to the listeners also again. What I tell people about the freight railroad is that it is one of the sexiest businesses you did not know that exist, or we took it for granted. Context, we form a very critical, and I talk about total United States, not just my company, but freight railroads in the US, we form a very critical part of our national transportation infrastructure. And we move more than 40% of our country's freight. The railroad is defined into four key sectors. The first one is our energy sector. We move crude oil. We move input materials to the crude oil. We process crude. We move coal. Then we have our agriculture sector, anything related to agriculture, soy, grain, others. Within the industrial sector, all the input materials that go into the manufacturing business, say plastics or other things, and everything coming out as processed goods through the industrial economy. And lastly, the intermodal, which is our multi-mode containers that come in from, say, Southeast Asia, China, Vietnam, wherever. They come by our truck to the dock, to the ship, to a port, from the port back to the trains, and back to our truck through the last mile, which is called inter or multimodal freight. Again, we are more than hundreds of thousand jobs supporting our US economy and being one of the most fuel efficient and environmentally friendly freight operations in the country.
Hey, thank you, Sunny, for this introduction because it tells us how impactful to the economy the railroad transportation is, to the benefit of executive leaders, especially those who are looking to understand the real world impact of AI on complex operational systems. Why do you believe AI is so crucial for the future of operational systems? How organizations leverage AI to evolve from a reactive to proactive decision making?
Look, I think it's important to understand why in the railroads operational systems exist in the first place. I think a decade ago, IoT became a very key buzzword. But the T in IoT, thinks, we have had since the 1960s. We've had sensors in the railroad every 15 to 20 miles since the 60s, and they have only been growing in technology, in capability. But our systems traditionally have been reactive. We respond to issues after they occur. But as I said, safety matters, efficiency matters, and cost and value for our customers, they all matter. Safety to us is not just about moving our freight safely. It impacts our employees, it impacts our customers, but it also impacts the communities that we serve through which we move our freight. So as we look into what has happened, the ecosystem developing around AI, particularly machine learning, predictive analytics, and real-time data processing, we move to what we call proactive, what does it mean for us? It means predictive maintenance, our ability to predict failures, to maintain before it happens, more anomaly detection through complex event processing, uh, more automated decision supporting, and frankly, in the end, it also is a lot about efficiency and resource optimization. The resources may be our trains or cars, the resources may be our people, or even the money that we put in. And how we leverage, again, you sort of mentioned it, it's a big data-driven culture, and investing in the right AI models, or if not the right, because the rate of change is very fast, then it's also about investing in scalable AI or things we can pivot from. And there is a big part of collaboration between OT and IT, and the whole feedback loop, the continuous learning and adaptability. So we see it as a fundamental enabler at this point. And I would tell you this is across the industry, not just our railroad.
Exactly, exactly. It's across the industry. We see a lot of adaptation in all those industries. I was so fascinated to learn that you have started this journey way back in 2014. I wanted to delve into that later in the conversation. At this time, I love to explore what this transformation looks like from a leadership and business strategy perspective as organizations embrace AI, especially in complex environments like transportation or infrastructure. What do you believe are the most significant shift that you see in your industry?
We in the railroad, we say be safe and be consistent. And by consistent, I mean I can have a mile and a half long train. If I told you I am a day early, you don't know where to park that and what to do with those. So we have to meet your requirements as a customer and be driven from what do our customers want from us. So with that, when we think about what are the business shifts created, I think for me, the some things that come to mind are going from sort of cost cutting to value creation, right? Technology, historically, we have seen automation as a means to cut costs and reduce efficiencies. And that is not going anywhere. Look, that will always be true. But where we are looking at how to unlock additional sources of value that we can provide with our customers, that we can partner. An example of this was a service called Quantum that we just started working on with JB Hunt, sort of white glove service to very specialized packages that we are moving in. Right. I won't go into detail. There is a lot on the internet we can read. It's called Quantum that BNSF and JB Hunt partner. And again, advances in AI helped us do that. And the reason of this was also real-time decision making, right? Real-time decision making is a buzzword for us. It's more about real-time operational intelligence, right? Little things. I'm a data guy, so little things going from batch processing to streaming events and streaming data with connecting yourself to the source of truth. it helps us in things like dynamic scheduling, fleet optimization. You look at weather, you look at train performance and other track conditions that may happen. Because again, we are a large company. There are individual departments doing their own things that are right in their own way. But stitching that data to give our information at scale is where the value is. And when I talk about scale, the another big advantage, I think, of AI is automation at scale. Automation at scale, to me, is something that is not complete at any given point in time, right? It will always keep evolving. The landscape of AI, especially with LLMs, is changing at a very rapid pace. So for us, it is how can we do more? How can we take technologies from one area and go put it in another area? And this leads us to a data as being sort of your key asset. So data gravity, data latency, sources of truth, all of that matter. And last, I would say, is customer-centric AI integration, right? Completely integrate into the supply chain. The holy grail for our industry is estimated time of arrival. Wouldn't it be great if you knew your container when it was packaged in China and when it would be at your doorstep in a complete end-to-end basis? And that is connecting across the board, not just within my own ecosystem.
Thank you so much for painting the clear background as an overview of the industry as well as the strategic priorities for this industry. So can you describe some applications being applied today to improve operational efficiency, especially in the context of critical infrastructure?
Yeah, I can go into two. There is a lot, but for our listeners, if you think of trains, there are two key things to sort of separate and understand where each play a role. The first is our fixed asset, our tracks on which the train moves. And the fixed assets, the obvious one is the tracks, but underneath the track, there are these ties that hold the tracks together. Underneath, there is ballast, where water can wash out in a certain way in case of heavy rains and other things. We have our tunnels, we have our bridges on which these move. Railroads operate a lot of bridges that lift up or move sideways so that the barges can go through. So, and the second piece, and I'll give examples in both. The second one is the trains themselves, right? It's metal on metal. So the brakes, the temperature of everything does matter. Now, in the first one, my example would be what we do for preventative track maintenance. And this is initiatives we started about, at this point, I'm approximating a decade ago, leveraging track geometry to feed track geometry data like LiDAR, like, X-ray and other things into edge compute models so we can first train the systems and eventually get to predicting failures faster. So we look at the condition of the rail itself to figure out if this rail needs surfacing now. Can it stay on its existing predictive schedule? Or in some areas where temperature swings happen between 30 or 40 degrees within one day, what do we need to go and accelerate maintenance there? And in some cases, replace the rail. So you have a new one. So that's one model. We took this model very recently and said, what are our absolute key failure points that we have seen over these past few years? And then we built hardware, a small one, that we are putting under our locomotives and trying to get real-time data out as these trains or engines or locomotives are running through our system. So to give context, we own 32,500 miles in the railroad. And we will be able to collect about 500,000 miles of measurement data every year. So a lot more visibility into the health of our track. The second example I would give, and we can double click on each one, Samuel, in a minute. The second one I would give is as these trains are moving, the trains are made of cars that are all connected together, and each wheel on each car has a brake pad. So we have put systems that look at whether the brakes were applied. Did every brake get applied? Because think of a car and a second car and a third car and a fourth car and a locomotive in the front. If the front locomotive applies a brake or releases a brake, there are dynamic forces that brings these cars back and forth. And a train could basically stretch and elongate hundreds of feet if it's long enough. And you want to avoid those dynamic forces because that's when bad things happen, like derailments. we look at the temperature readings on these brakes to say, hey, the brake was not released, which means now we are dragging a car because the temperature is high. The second thing we do is we look at the wheels itself. So there are camera arrays along our trackside at a few locations, which are capturing multiple pictures of every wheel as the train passes by. It could be at 70 miles an hour, it could be at 40 miles an hour. And we take about 3 to 4 million images every day. We process them at the edge, look for little things like, is it truly a crack that is developed? The severity of the crack. We look at, no, it's not. It could be a wheel chip, a paint chip. It could be a little piece of wheat that is stuck over time. And then determine the next course of action based on the severity. The goal is sometimes these cracks, whether it's the plate, the rim, the tread of the wheel, that can cause, again, bad outcomes. And our goal in the end is to move safely for our customers and the communities we serve.
What interests me in this case is that you explained to me, once it was very manual. I believe earlier it was geometry cars running on the rail and check on physically, manually, and see what need to be fixed. And the train reached the station again, checking everything, and then let it go. From there, it's AI-driven, automatic, real-time monitoring. It's so fascinating. I'm looking at what you have done, 32,000 miles railroad. And on the locomotives, you have put hardware behind it, so you can record those rail conditions real time. On the top of it, the second application that you told about, putting the cameras or sensors in every 15 miles or so to capture the wheels and the brakes when it runs, the actual, how it's heating up and the conditions of it. That means a huge capex. And even the OpEx also, when you're talking about, in order for this to process this on the edge and transferring this data to the cloud, and then combining with the real-time weather data, we're talking about massive processing computing power. So it's both in terms of capex and opex. It's so heavy. So it would be useful for the listeners if we can walk us through the journey, obtaining the buy-in from the leadership. For initially at that time, this was pretty new. Decades ago, it wasn't much of adoption at the time. So how was the journey like in terms of getting a buy-in, then from the buy-in to a pilot and into a full-scale implementation?
Yeah, that's the daily grind, isn't it?
Yeah.
But I do have to give shout out to our leadership in our company, our CEO, our COO. We have a very strong leadership and vision driven by, again, as I said, our people, our communities, our employee, our shareholders, in this case, our owner. And the entire leadership and vision has always, everything we do in the railroad starts with a safety briefing. It is not a choice safety. We call it a thing we do because it is very intentional. So with that, the growth of technology is not organic. It is not like one guy sat in a cube and came up with a genius idea. Sometimes we learn from industry forums. Sometimes we learn from what competitors are doing. We don't compete on safety. Sometimes we learn from vendor partners, and sometimes it's organic growth within. But as all of this, the aspect that is not lost on us is the ability to keep learning. And learning gives us the ability to go ask critical questions to then build a plan. Does this apply to us or does it not apply to us? So I don't exactly remember. I won't claim to know how something like a track maintenance geometry car came into the beam. But over time, when we looked at the data and we explained the ability to our leadership, or my team coming explaining to me and me going explaining it to the leadership, that while we have these geometry cars, there is a consistent OpEx and refresh CapEx. IT is expensive, really, when you put GPUs, CPUs everywhere. And we could scale this at a much larger footprint with a smaller cost if we could go start and dabble in something. That ability to dabble, we created room for our teams. So it started with strong leadership and vision, and then a lot of cross-functional collaboration as well. So that sort of sounds easy, right? I mean, to our listeners who are really going through the challenge in an organization. What I'll tell you is starting in a lab is literally how we started. Going through tons and tons of iterations to make it better and stuff was, you can think of as an R&D think tank within a small subset of folks who are going and iterating this. Then comes the sustainability aspect. And we look at, I'll give you an example of our vision models that where I'm saying I'm taking 6 images of every wheel as it goes by. We have to pump a lot of money, not just in the hardware. Once the hardware is done, even fine-tuning software is very expensive. And we had to go and sit down multiple times to figure out, as you calculate your harmonic mean, your precision versus recall, we had to go look at, this is costing a lot of money, annotating, identifying, fine-tuning the models to say, is 85% done or is 87% done? And then we had to go break it down model by model. If I'm looking at a wheel plate, if I'm looking at a rim, and I'm looking at the tread. In some models, 92, 93% was achievable, but after that, we ourselves did not have an idea what it meant to take it to 97% accuracy. And that means you're covering for false positives because we cannot have too many false positives. Then you're stopping trains for the wrong things. And that just is a supply chain crisis. And the second is if you're having too many true negatives, then we didn't build the model right. So how do we know what we don't know? And those analyses take a lot of time. And we have to come as leaders to a conclusion that there is a definition of done. And that does not have to be 100%. These models, chasing 100% is chasing perfection. What it means is with the limited resources any IT organization in the company has, people, time, money, by putting all that time and money in an area where we are chasing perfection and we are nearly close, might as well go pivot to something else because the rate of change is very fast. I hope I answered in a roundabout way, but to me, it does boil down to a strong leadership vision and a cross-functional collaboration. And where BNSF, I truly, truly, truly believe we are unique is BNSF has pillars that we call the pillars of our company on which we exist. We align, we allocate our money, we allocate our resources, we look at future of the railroad. And my CEO went with a leadership team this year or last year, I don't remember, and put artificial intelligence as part of a leadership pillar of BNSF. So now it is a part of everybody's business, not just the tech folks. I can give an example on the first one being the hardware-based, where we are building our own small hardware with a Linux operating system that goes underneath a locomotive, measures certain variables of track geometry, can upload via cellular or come offline and upload data to the cloud. The hardware alone took us time. There is a fabrication aspect. We don't know what we don't know, how it goes failing. But then operating system, little things like latency, sensors, where do they need to be placed? What are they measuring? Is it 0.5 mm? Is it 2 mm? What is the variance in the measurements? What is my setting up the back-end baseline of what the models are? And again, reference data matters, right? How do we know we are 90% accurate? It is based on the geometry cars in the past they ran. So first is training that. All of that took us a good 6 to 12 months. And I will tell you, even right now, we think we are ready, but I know in my heart that at scale deployment, very quickly, we will find things that we didn't think were part of our problem. So there will be some iterations, mostly on the software side, that we will find and continue to tweak. And the goal at some point for leaders like me will become, is it worth spending the effort? Is that end 1%, 2%? I don't know what that percent is really. Is it worth it? Or should we just pivot to completely generational change? Because at some point that hardware has to be refreshed. So leaders, my job is to think of, we put the hardware today, how long will the hardware survive in that extreme condition where the locomotive is going up and down, there is forces, lateral, vertical, and with all of those. So if I'm refreshing 5, 6, 7, 8 years from now, what does it mean at that time? What will my goals be at that time? In all of this, I think the other aspect I cannot emphasize enough and think about, I did not touch it, is data security and data privacy are extremely important. So I used to run the network team, and we have segmented our network very well. We keep certain data within certain bounds. But a lot of this data is transcending a lot of systems, the OT and IT systems. So what do we do? Encryption at rest, encryption in flight, data privacy. Then there is, if we use the modern LLM approach, then governance, accountability, and also ethics of AI, all of this has to matter.
I wanted to know how you scaled it up to cover up the 32,000 miles of rail.
I think this is where, as an IT guy alone, I don't even know what scale really means, right? You took of, like, if I were to go tell my kids, hey, we have 32,500 miles of track, how much should I measure and monitor? And they'll say, oh, you got to measure and monitor everything. That's the obvious answer. But then this is where collective wisdom comes into play. If I go talk to my business leaders, folks who run the trains, folks who manage the track, they will tell me this many miles of track is our core bread and butter, and it carries 95.6% of our freight. So that is not 32,000 miles. That's a lower number, right? But I think I, I don't want to use a small word like curiosity, but that collective decision to understand scale helps us, because there are things I won't understand about our business. Those are the folks they understand. But when we sit down, when we show I'll give you an example of the vision models that we measure 6 pictures of every wheel as it is going by. We are not putting it every 100 miles on the track. We are not putting it every 500 miles on the track. We have systems and teams that are managing the entire network, because what we know with our data is it takes time for a wheel to fail. So where we go put that matters. It's not perfect at the start, but over time that starts taking a sort of a science of its own to say, if I had 30 systems, 40 systems, it's good enough to cover and give me enough buffer for us to go maintain and predict wheel failures before they become catastrophic issues. And that analysis is going into measuring where our freight is, what type of freight is. For example, coal cars are heavier, but coal cars don't move at the same volume everywhere on our railroad, right? Heavier means more weight on the track, which means more degradation of track. Where we have curve on our track, where we have grade, you're going incline or decline, those areas become more important. Where we have weather variations, especially Montana, we last year put a significant effort into doing continuous welded rail operation because the temperature was swinging 30 to 40 degrees in a day, and that's when track buckling happens. So a lot of this IT has to be curious with our business on what does it mean, rather than just designing a solution. Just think it 2 steps ahead and giving the magic wand to the business and say, if you had a magic wand, what would it be? And then we can go and parse the technology and stitch to come in the middle somewhere.
This is where the inter-team collaboration comes into play for a successful IT projects, because more than technically a solution here, we need to think how it can be implemented in the real-time scenario. So that's what I was thinking. How did you implement? This makes a lot of sense, where you identify high-risk areas, put the cameras there, you saw where our base is covered when you start with. So that way, that's the right approach.
In IT, we do stand-ups and we do retros.
Yes.
I mean, the concept is the same. We have to apply it with our business partners, right? Learn fast, fail fast. Be very iterative in our approach.
This showcased the real-time example of the need of such kind of meetings, actually. It's not theory anymore. Initially, when we were considering how to prioritize these initiatives, because all these are competing priorities for capital, and how did the executive leadership prioritize this initiative one over other?
We have a very rigorous process in our company when it comes to CapEx analysis. Mm-hmm. And so far, it is still the old school way. Meet with the business partners, go figure out what the value is. I think financial discipline in our company is pretty strong. I'm very blessed that way, where we go do an ROI analysis of all key initiatives and figure out what the ROI could be. So there is a good aspect to this, but then go measure it in the back to say, hey, the ROI is not delivering what it is. So is this become theory at some point and we kill the project, or we keep investing in it because we see the art of possible? So those analyses do take some time. We start our capital planning process in theory sometime in August timeframe for the next year, right? Again, these are not too super time consuming. I won't say they take too much time, but just meeting with our business partners. And the railroad is made of engineering department that manages everything on the track, the mechanical department that manages all the locomotives, the cars, and intermodal department that manages all our yards around, hostlers and cranes and everything, and then the transportation folks who run the railroad, right? So within those folks, there is a lot of continuous meeting. And as I was talking about the concept of retros, this is not a surprise at the year end to plan capital for the next year. If you have proper retros, you are figuring out over time iteratively whether these programs need money or they don't need money. And in many areas, IT will get more money if the value is higher than going and building another 2 miles of track, because building track is very, very expensive. So if we can, without building track, go figure out safety use cases or velocity, which is moving trains faster, which means creating more efficiency in the railroad, even 0.1 mile per hour, right? That will always be a higher priority for our leadership team. And I'm oversimplifying, but an underlying assumption is people work with each other, they're willing to listen to each other, and you create a culture where hard conversations can happen.
I can't agree with that more. Sunny, we have listeners, both business leaders and technical leaders in this podcast. From a technical standpoint, how did your team manage the underlying data architecture and computing stack? And especially considering the need to coordinate, like initially I mentioned, edge processing, cloud training, and real-time data streaming. So how did it all come together? How did you manage? If you can take a minute or so just to say how the architecture looked like, that would be useful for CTOs and other technical leaders that listening to this podcast.
I'll share this. We by no means are perfect on our data stack today. There is a very long journey to go because we ran the railroad on a mainframe for a very long time. The source of truth then was in the mainframe, but that would go to DB2. So in some areas that where we have seen the fastest success have been ones, as I mentioned, the machine vision models for our train wheels or brake health on temperature or measuring the cars. A lot of this data was generated by the system itself. And there were limited dependencies on other systems. But what we were doing is let me step back and say, when data is generated from an individual system, at the end of the day, the goal is, what decision are we taking? Is it inform Samuel that something may go bad? And Samuel says, okay, at my next regular scheduled maintenance, I'll take action. Or is it, no, I want you to stop the train at your next scheduled stop, or stop it now, right? And I'm oversimplifying this. But let's take the second scenario, do something at your scheduled stop. We have to now go and get data from other systems to understand what that scheduled stop is, how much time that scheduled stop is, what is the impact of weather along the journey. And taking all of this sort of creates a complex event processing engine. And the other part, I should have mentioned this before. Our models are not 100% accurate. So if I take a vision model, and the model is only 83.5% accurate, let's say, based on all the data that we know, there is a 16.5% chance that it is wrong. So now we take data from other sources with other detectors, like a force, like an acoustic bearing or temperature reading, to go stitch that data together to build a confidence score. Based on that confidence score, to identify the actions that we are taking. And for all of this, stitching that data matters. And we did this very organically, right? I mean, engineers get together, build a block diagram, and you start doing that. And then we learn, oh, well, if that system went down, everything else in the front end went down. And say, okay, we didn't do what we call a microservices architecture. We did build SRE in our application. So you go start, you decouple it. If everything was built in the cloud, life is a little easier. We are not. So we are in that journey to go in that model where each application sort of can be self-sustaining in their own way as we look for the next gen of transformation. But the key philosophy will be connect to the source of truth, right? And sort of within an application, control your own destiny. Don't be dependent on everything else in the future. We have a hybrid data presence. Some of it is on-prem. As I mentioned, things like DB2, where we look at train schedules, we look at train makeup, we look at crew availability, way bill of the customer. And there are some like Azure Data Lake, where we are getting all this data ingested from our track and wheels and stuff, where we are doing post-processing. We have events being generated at the edge, either on a geocar or at our what we call bungalows by the trackside, doing a lot of edge processing, executing models that we already built, stitching it all together with additional sensors, with additional data, is then done on-prem to take action number 2, 3, and 4 out of this. So I know I did not give you a good answer, but it's because it is not an ideal ecosystem that I can build a block diagram. Right? The key thing is moving towards streaming data, real-time data. We are building goals like 5 seconds, and with data gravity, with the right catalog, that's our goal, and we have started that journey.
Yes, Sunny, thank you. Thank you so much that you highlighted the operational technology that's currently used, because for the customer integration, it's very important as well. If I am a customer of yours and if I need to send some goods to another location, what's important for me is will it reach on time? If it doesn't reach on time, it's going to affect my bottom line. So the providers' technologies and the ability to deliver the service on time, it's critically matters. So in that context, having this showcase is very important. And what emerging technologies or innovations do you see transforming this industry in the next few years?
Yeah, I think we didn't even cover the entire topic of LLMs and what it scales further, right? The just recent announcement from Anthropic Claude 4 ran coding for 7 hours itself. So if I look at all of that, and I'm a believer of this, in fact, there is a DeepMind study I got to go synthesize. AI coupled with robotics into the concept of humanoids, I think autonomous systems and robotics will have a very, very big deployment scale in the future. And I think this is, again, a combination of AI, machine learning, robotics, sensors. We can look at things like automation in train movement. We can look at our automation in freight movement generally, like things even like drone-based delivery, warehouse robotics. So warehouse robotics for us would be our yards where we store those containers, where we store the customer's freight, right? The second would be predictive analytics will go faster. And this is not just transportation, right? Every industry, look at energy, supply chain management, anywhere. This is faster. And then you look at natural language processing, you look at conversational AI, what I like to call generative BI, will give information, not sources of data through a Tableau and a Power BI and a SAS report that the end user has to stitch together. You get into more, this is what I need to do, what should I do? Right? I think those capabilities are developing much faster than we in companies can keep up with. But the way I talk to my team, the way I talk in our organization is we are figuring out what does it mean to be an AI first organization? What does it mean for us, not the theory of it? So we can pivot to that.
Great. The scale of change AI could bring over to the next decades, not just like you said, not this industry, across the industries. It's so fascinating. And for leaders listening to this podcast, the big question is, how should they prepare for it? What should they do today to be prepared for this? So if you can give a few words of advice to the leadership, that would be grateful.
To me, it starts with accepting first. I see this sometimes that there is we know our business and we can talk AI all day long. I listened to Indra Nui many years ago, and she said the whole concept of the employee learns something, creates a PowerPoint, go convinces the boss, and then they create another PowerPoint, and then they convince the super boss, and then they create another PowerPoint and convince the super duper boss. That world is gone. Leaders have to go back to school and learn what this means, because the rate of change is significantly different now. And with then only then when we have trained the top will we understand what in this environment, in this economy, in the future leadership vision mean. Then we have to sit down and understand cross-functional collaboration on what this means for all of us. I'm not going to belittle our leaders on the group. I think they're running strong shops and they all understand what they're doing. But the one aspect I would ask everybody to keep in mind, I keep in mind, is ethics, governance, and data security. Those to me, are key pillars of an AI-first organization.
Thank you, Sunny. In a complex and high consequence environment like freight transportation, we're using AI not just to predict failures or to optimize operations, but to elevate safety, as you mentioned, reduce cost, and create real-time intelligence at scale. But none of this happens in isolation. Success depends on cross-functional collaboration, strong leadership, as you mentioned, and a culture of continuous learning. As leaders, our role is to remove barriers, build communities of practice, and ensure that we become a trusted partner, not a black box. The future is already unfolding. The job is to shape it responsibly. And thank you so much. Thank you so much, Sunny. It's a beautiful conversation. I'm sure I'm going to bring you back again. There is a lot to talk. And thank you so much for sharing your insight and experience. And thank you to our listeners for tuning in. Until next time, stay curious and keep pushing the boundaries of what AI can achieve. Thank you.
Thank you for having me today, Samuel. Thank you.
If you like today's podcast, please be sure to leave a 5-star review. Your feedback is important. We always look for comments and recommendations to improve. This show is available on Apple Podcast, Google, and SoundCloud. Please do subscribe. Plus, you can find us on LinkedIn, Twitter, Facebook, and on YouTube. You can find the links to these pages in the show notes or by visiting us at AISuccessFactors.com. We publish episodes bi-weekly on Wednesdays. Please be sure to tune in for the next episode. Thank you and see you next time.